Hello, once again. This is the last assessment statement in 3.3. So 3.3.7 wants us to explain how this thing called non-disjunction up here can lead to changes in chromosome number. And we know this because we can see this in Down syndrome. So if you remember in Down syndrome, and this thing is in the way, if I try to make it fit. Let's try to get this out of here. A little better. So if you remember when we were doing karyotyping and we were looking at different chromosome numbers, like homologous chromosome numbers, similar banding patterns, one of the abnormalities is when we have 3 chromosome number 21s, and that is called Down syndrome, right? So what we need to do is we need to be able to explain how that happens. And there's two ways it can happen in non-disjunction. So let's go ahead and look at those. So I have a little diagram here so we can illustrate those. So you guys are all smart. If you remember that how meiosis works, the first thing we need to do is we need to make copies, right, of our homologous chromosome. So here, pretend this is one from your dad and here's one from your mom. And let's pretend that we're only looking at chromosome number 21 because that's how Down syndrome works. So we made a copy of the blue chromosome, and then we'll make a copy of the red chromosome, and they're attached in the middle by centromeres. These are still homologous chromosomes. There are still only 2 chromosomes in this picture. There are 1, 2, 3, 4 chromatids, but there are still 2 chromosomes. So one thing that can happen is that both of these chromosomes, so both of the red chromatids, so that homologous chromosome, and both of the blue ones, both those blue chromatids move over here. And then when they divide into the gametes down here, you'll have 2 blue ones. Now they're called chromosomes again, right? 2 of those blue chromosomes, and on the left-hand side, we'll have 2 of the red ones. And the problem is, let's pretend that this is an egg. If a sperm comes over, let's say with 1 copy of chromosome number 21, then this zygote, right, this developing embryo will have 1, 2, 3 copies of chromosome number 21. So that's an example of non-disjunction resulting in too many chromosomes, which we call trisomy. That's when you have 3 copies in meiosis 1. And if we look over here, there aren't any chromosome number 21s, right? So if a sperm came with its 1 copy, there would only be 1 copy of chromosome number 21 in that developing embryo, and that's not enough. That embryo would probably be miscarriage. Okay, so let's look at a different example. So let me erase all this. Well, not all of it. So let's pretend that this first meiosis went swimmingly. So there were no problems. So that homologous chromosome moved over here, and this homologous chromosome moved over here. But then you can have a mistake in meiosis 2. So let's pretend that on the right-hand side, everything went okay. However, on the left-hand side, both those, that homologous chromosome, both of those chromatids moved into 1, and then we have an empty egg over here. So here we have it again, right? So a sperm comes over with its 1 copy of 21. If it fertilizes this one, we will have someone with Down syndrome, 3 chromosome number 21s, 1, 2. I don't know why I connected those. If I did that correctly, I should have, right? Should have done it this way. Right. 3 copies of chromosome number 21. This one would not be viable. However, on this right-hand side, there is a chance that you could have 2 healthy individuals. And that is non-disjunction.